Other sensors, such as the water and fuel sensor, act as simple switches providing an on-off signal. When the water in the bottom of the fuel filter reaches the contacts in the sensor, the water completes the circuit between those contacts and causes the warning light to illuminate. Some pressure sensors work by capacitance. The pressure sensor contains a disc that has the pressure to be measured on one side and the reference pressure on the other side. Pressure acting on the disc causes it to move toward or away from a second metallic disc. As the gap changes, the capacitance also changes. An integrated circuit inside the pressure sensor converts the capacitance value into a voltage signal that is proportional to the measured pressure. A gauge pressure sensor has atmospheric pressure on one side. It is vented by a hole in the sensor or through the stranded sensor wiring. The pressure measured by these sensors depends on the atmospheric pressure, just like a mechanical pressure gauge. This type of sensor indicates 0 when it is at atmospheric pressure. An absolute pressure sensor has a vacuum on one side. This type of sensor provides a signal representing the total actual pressure. This type of sensor reads approximately 14.5 psi when it is sensing atmospheric pressure. The barometric pressure sensor, also known as the ambient air pressure sensor, is an example of this type of sensor. Some pressure sensors contain a crystal structure. Pressure compresses the crystal, creating a small voltage proportional to the amount of pressure. This is known as the piezoelectric effect. With this type of sensor, the resistance can be measured to verify proper operation. However, the resistance range is too large to verify sensor calibration with a resistance check. The sensor calibration is checked by comparing the reading in InSight to the reading on a mechanical gauge. Piezoelectric sensors are also used for combustion knock detection on some engines. The ECM controls the air-fuel ratio of gas-fueled engines. To do this, the system must measure airflow and fuel flow to the engine. Fuel flow is measured with a hot wire type gas mass flow sensor. The ECM sends a current through the wire, heating the wire. The natural gas flowing over the sensor tends to cool the wire and lower its resistance. By monitoring the change in resistance, the ECM determines the quantity of gas flowing. The accelerator position sensor is another variable resistance 3-wire sensor. However, the variable resistor is a sliding contact type resistor connected to the accelerator pedal. The accelerator not only contains a position sensor, but may also have an idle validation switch incorporated into it. This is a safety redundancy check to help ensure that the accelerator is not malfunctioning. The accelerator position sensor and the idle validation circuits work together. In the idle position, the switch indicates to the ECM that the pedal is at idle, and the accelerator position signal to the ECM is low. The ECM knows to ignore the accelerator position signal and provide the set idle speed for the engine. As the accelerator is depressed, the idle validation switch indicates off-idle status to the ECM. At the same time, the accelerator position voltage increases. The ECM now uses the signal from the sensor to determine the operator's desire for speed and power. The switch position can be either latched or momentary. A latched switch maintains the switch position when the switch is toggled, such as a cruise control on-off switch. A momentary switch only maintains contact as long as the switch is held in position, such as a cruise control set-resume switch. A single-pole double-throw switch has 3 positions, 2 closed and 1 open. This type of switch completes one of 2 circuit paths. A double-throw switch cannot make contact with both circuits at the same time. A common single-pole double-throw switch used on this engine control system is the engine brake switch. This shows a double-pole single-throw switch. In effect, this can be thought of as 2 switches that are ganged or mechanically linked to cause them to move together. The switch pole refers to the number of switches that will move together. This double pole switch has two separate contacts in separate circuits. With a double pole switch, when one switch is moved, the other switch moves with it to either open or close the electrical path in the other circuit. Switches can be energized mechanically, hydraulically, or pneumatically. An example of a hydraulically activated switch includes a pressure switch that opens or closes when it senses a specific pressure. An example of a pneumatically activated switch in an electronic engine control system is a brake light switch. For most control systems, when the switch is closed, the supply voltage is pulled to its low level. This indicates the switch position to the ECM.